Our collision detection is working, but our explosions are a bit boring. So, let's pep them up a bit. Let's get coding. Hi, and welcome to Bytes and Bits. I'm Bob Grant, and this is Lesson 7 in the Learn to Code Asteroids course. We've pretty much got all the parts of our game coded now, so we can move our ship, shoot, explode asteroids, and hit asteroids, and have our player ship explode. But as you saw in the intro, we need to pep up those explosions and make them a bit more interesting. So in this lesson, we're going to be having a look at something called particle effects, which will actually then create these explosions. So let's go into our code and see how we do that. If we have a look at our asteroid explosions to begin with, once an asteroid is hit by one of the player bullets, we need to remove it from the screen, but then we need to trigger this idea of the particle effects. A particle is basically just a small image. It could be a circle, a rectangle, or even just a single pixel. But we spawn those at the position where the object has been exploded. We then give each of these particles a velocity and set them in motion for a short time. And this gives the effect of all of these particles then exploding out of the position where the asteroid used to be. So we're going to start by creating a simple model for our particles. So tying this in with what we've done already with some of our on-screen objects, we know that our particle has to have a screen position, which is denoted then by its x and y coordinates. We've already said that we're going to give them these random velocities, so again we'll have to give it a velocity attribute, which will have of course the speed and the direction. Now each particle then needs to live for a certain amount of time, and we're going to have to randomize that so we don't have all the particles just dying off at the same time. They'll sort of tinkle away in the background. So we're going to have to add some sort of life timer to each of our particle objects. And this then gives us the basis to start coding our particle effect system. So loading up our game code then, we can start to code these particle effects. So they're going to have a very similar format to our asteroids. So if we come down here then, we can see that this is where we're doing all the stuff for our asteroids. But after that then, we can start adding in our particles. So we're going to need an actual table then, which is going to hold all of the individual particles. And really what we're going to do is we're going to throw particles or particle objects into this array and then have both our move and our draw functions attached to that, which will then move them around on the screen and eventually kill them off after their lifetime has run out. So once we've got our particles array, we really need then 3 functions to handle our particles. So we're going to need a function which is going to spawn a particle, so that within our code we can say spawn a particle and put it on the screen. We'll then need to have a function which will move all of the particles, and then a function which will draw all of the particles on the screen. And somewhere within that code as well, we're going to be running this timer effect and then removing the particles once they have died. So really that's what we want to do next. So we've got the array now, and we really want to have these 3 handler functions. So I'm going to put that down at the bottom of my code. So I've got 793 lines there. I can use this goto tool here, and I can just say go to line 793, and that will take me down the bottom very quickly. So down here, I just press return, and down here then, so I want a function called spawn particle, and that's the end of that function. I'll want a function called move particles. That's the end of that function, and a function called draw particles. So again, you can see it's very similar. Particles. This would be very good if I could type anything today. So draw particles, and that will be that. So we've seen then that this is very similar to any of the other things we've done. So we need something to create them, to move them, and to draw them on the screen. Now we think about our spawn. We've already covered the idea of what's going to be inside a particle object. So when we create the particle, we will need to send it a position. We will also need to send it a velocity. And we will need to tell it how long it needs to live for, or at least what the maximum lifetime is going to be. So we'll call that max lifetime coming in there. And these three values then, if I just go to a smaller font size, so these three values then will be used to create a particle object and drop it into the particles array. Our move particles one then, again, we have an object with a position and a velocity. So our move particles will be very similar to any of our other move routines. And again, a lot of the code for using positions and velocities is already written for that. And what that should do as well then is have a look at this timer. So again, we're going to use this max lifetime value in the spawning function. And that will add this life timer attribute into the particle object. That will need to count down every time we move the particle, and when it gets to 0, then that's when that particle needs to be removed from the particles array. Our draw particles then needs to draw the particle on the screen, and for now all we're simply going to do is just draw little circles where these particles are. So there is a circ command in Take80, and that simply then accepts the x and y coordinates of the center point of the circle, the radius of the circle, and then the color. And again, if you want to, we can set the color to be 15, which would be the white. Or again, it's up to you what you do on that. But that's what we'll use just for now. And what we'll do is once we get this basic particle system working, we can then start to expand it and customize it to give us lots of different effects. So, see if you can add these three functions into your code, and then we'll come back and see if we can get that to actually work when we hit an asteroid. So I'll give you a few seconds on the countdown timer and see you in a wee bit. Okay, so let's go through this code then to make sure we've got it all correct. So we're going to look first at our spawn particle function. And as I said, we're going to be sending in a position, which will be the position of the asteroid, and eventually, of course, the position of ships and so on. The velocity that we want this particular particle to have, and then the maximum lifetime that this particle should have. So we're going to do as we do normally then. So we're going to create a local variable, which is going to let us build up this particle object. So our particle object then has to have a position. Now if you look at this position, I'm actually setting it to the position.x and position.y. I could, if I wanted to, have tried to do it, if I just take that out, as position, because we have a position object coming in. So you might think that it would be easier just to do position equals position. But this actually causes us a problem. This parameter coming in is actually a reference to the position object of, let's say, the asteroid that we've been using. So we're going to call this, we're going to say spawn particle, and we're going to say asteroid.position. So that will actually be the position object from the asteroid. Now if we then come in here and say position equal to position, what that will do, that will link the position part of our particle to the position object of our asteroid, and in effect they will both refer to the same thing. Again, because we're passing in an object reference here. So you've got to be very careful when you're doing this. If we want to actually make a separate position copy, we have to create a new position object and copy in the parameters from this one. So that's why in here we're not doing that. That would actually mean that our particle position and our asteroid position would be linked together and they would move around together. So I'm simply going to do an actual copy. So we're making this position object equal to a new Lua table, and we're setting its x attribute equal to the value of this position object's x attribute, and then y equal to position.y. So that will give us our own separate position, which we can then of course manipulate inside the particle. Same with our velocity then. So we're making velocity equal to a new table, and again we're copying in the velocity.speed and the velocity.direction from this incoming parameter. On the lifetimer side then, again we're going to make it a random lifetime. So we want some of the particles dying off quickly, some of them dying off slower. But what I've done here then, I've said, okay, so max lifetime is the maximum amount of time we want them to have. But I'm saying that I want the minimum lifetime to be the half of that max lifetime. So the way I'm working here then, so math.random gives me a number between 0 and 1. So I multiply that by the range of values I want to have. So I want to be going from half max lifetime to full max lifetime. That gives me a range of values which is half max lifetime. Okay, so this will give me, so this here will give me a number between 0 and max lifetime over 2. If I then add in my base value, max lifetime over 2, so that will now be max lifetime over 2 plus a number between 0 and max lifetime over 2. So can you say I will now have a range of lifetimes between max lifetime over 2, my base value, and my range, so up to 1 full max lifetime. Okay, so that's how we use this math random. We have math.random, we multiply it by the range, and then add on the minimum value we want to have. And then as we've done before, we're simply taking our table.insert function and we're saying this brand new particle I've just created, add it to my particles array. And that should then add the particle into the system. We then need to move our particles. And again, we've done all the code for this already. So we're going to use a for loop, which is going to use this I pairs on our particles array. And we're going to pull out the index and particle. When we move it, we're going to count down this life timer. So if the life timer has got less than 0, then this particle is dead and we take it out of our particles array. Otherwise, we update the particle's position by this function we've already written. And again, we use this both in our asteroids and our player ship. Okay, so we simply give it the object it wants to move. It will then look at the position and velocity and update the position and send that back to us. And that's all we need to do inside move particles. Inside our draw particles then, again, we're simply doing it simply at the moment. So we're using our for loop with the I pairs to work through every particle and just simply drawing a circle, a little radius 2 circle wherever that particle happens to be. So those are our 3 functions then to get our particle working. What we need to do then is to hook this into our system. So if we go up to our tick functions on our do play game function, so remember this is our main game playing function, and inside here then we say inside our update function, we will of course need to make sure that we move our particles. And inside our draw function, we need to make sure that we draw our particles. So that should be our particles completely built into our code now. We've got the handling functions all written, and we've then got the movement and drawing parts put into our main tick. All we need to do now is to generate some of these particles to create an explosion effect. So we do have a function called explode asteroids. So if we go to explode asteroids, at this point here, this is where we now have actually hit an asteroid and we want to blow it up. So we can see here we're handling scores and making the explosion sound effects. So at this point, this is where we want to make the explosion graphics. So let's have a look at what I've put in here then. So again, we're going to create a number of particles. So I'm creating 40 particles. So I'm just doing a little for loop, which is going to count from 1 to 40 and generate my 40 particles. I want each particle to have its own random velocity. So I'm using a little local variable here so that I can build up each particle's velocity. And I'm then saying that I want my particle's velocity equal to a speed, which is going to be this math.random times 1. So that will give me a speed of between 0 and 1. And my direction then will be math.random times math.pi times 2. So remember, we're working in radians. So 360 degrees is 2 times pi. So this will give me a number between 0 and 2 pi. So 0 and 360 degrees. So that will give me a random velocity, so random in both speed and direction. And then I simply want to call my spawn particle function, one that we've just written. Remember we said we were going to give it the asteroid's position, and it will then make a copy of that. We give it our local variable, which is this particle velocity. And then our max lifetime, and again this is measured in ticks, and remember we have 60 ticks per second, so I'm going to give it a 1 second lifetime. I mean, that's our maximum lifetime, so we'll be getting lifetimes between 30, which is half of that, and 60, which is 1 times it. So that should give us now an explosion effect when we hit an asteroid. So let's have a look and see if that actually works. And remember, all of this code will be in the course project page. I'll put a link in the YouTube description so you can go straight off to that. If you're already on my Bytes and Bits website, then the code will be down below this video somewhere. But make sure you go through that. So if you haven't had time to work it out from the screen here, all of that code will be available for you. So let's go and run this then and see what happens. So Control R to run it. And into our game, and let's shoot an asteroid, and there we have our explosion effect for our asteroids. Oh, and again, we don't have yet one for our player ship, but we do now have a reasonable explosion effect every time we shoot the asteroids. So let's come back out of that and back into our code. Now, one thing I did notice there is that our explosions have a bit of a pause when our player ship gets killed. So we did have a look at how we keep things going, and we do have a function called do no ship display. So if we go to that, okay, so what happened here was when our ship gets exploded, we keep our asteroids and everything moving in the background, but what we weren't doing here was we weren't keeping our particles moving and expiring. So when our game restarted then, it had all of the old particle effects still left over, and they would then suddenly spring back into action. So while we are waiting for our ship to respawn, we do need to come in here and we do need to do our move particles function. So that will keep our particles moving, and of course that will also kill them off once they've reached their lifetime. And we obviously want to draw them on the screen. So draw particles. Draw particles. Okay, so that should mean then that once our player ship gets hit, if there is an explosion taking place, it will finish while we are respawning, and then we won't have sort of spurious explosions happening when our game restarts. We've now got a completed particle system, but again, if we have a look at that, we've got our main things, and we have this white effects coming off from it. What would be quite nice to do now is to start work on improving that effect so that we can get even nicer particles. And the first thing we're going to do is we're going to have a look at changing the colour of the actual particles. So at the moment they all spawn as white particles and they stay white throughout their lifetime. But let's come back down to our spawn particles function. At the moment we are specifically drawing them all as a white circle, and again that's in our draw particles. Down here then we are doing this circle and we're drawing them as color number 15. But what we'd like to do is to be able to tell a particle what colours it should be. We're not going to just give it one colour. What we're going to do is we're going to give it a range of colours. And if we give it a range of sort of, let's have a look at the colours we have in here. So say we gave it some sort of fiery colours. So we've got our red and our yellow and our orange. What we could do is we could give it those colours, and then as it's drawing itself, every frame, so every tick, it can choose a new colour to draw itself, and that will make it sort of shimmer in these fiery colours as it's moving around the screen. So let's see how we could actually implement that then. So if we go up to our tick function up the top here. So we've got our particles. If I just come out of here, come on. So we've got our particles being defined at this point in time. What we could do now is we could actually define some colours. So let's create a new variable called explosion colours, and we're going to set that to a Lua table. So remember, we can use Lua tables to hold just an array of numbers. So if I go into my sprite editor, so black is number 0 colour. So 1, 2, 3, 4, 5. So 6 is red, 7, 8, 9 is orange, 10, 11, 12, 13 and 14 is yellow. So if we use 6, 9 and 14 as our colours, so I'm going to do 6, 9, 14. We now have a little array that holds our explosion effect colours. And what we're going to do is when we explode our asteroid and we do our spawn particle, what we're going to do is we're going to pass those colours into the particle. So we're spawning a particle with its position, its velocity and its lifetime. After that then we're going to do its colours. So we're going to use our explosion colours. We're going to pass the whole array into it. Okay. So if we now go down to our spawn particle effect, SPAWN, and spawn particle. So we know that after our lifetime then, let me just come down here, we're going to want to send in some colours. And all we're going to do is we're going to log those colours into our object. So we've got our lifetime timer there, and we're going to say, so colours equal to colours. Now again, we've got that idea where we're passing in a reference to an array, and we're simply going to copy it across here. But because we're never going to alter these colours, we're only going to read it, that doesn't actually matter. So as long as we're only using this as a read-only variable, then we can just simply copy across the reference. So that now means that when this particle is spawned, it will have this colours attribute, which will be an array of valid colours for this particular particle. So if we come down to when we draw the particle then, so instead of drawing it as number 15, we're going to try and work out a colour for this particle. So let's have a variable here called particle colour. And inside our for loop then, we're going to continually work out what this particle colour is going to be. So let's just copy that for now. And let's just define this as a local variable so it doesn't confuse anything outside of our code. So we're going to set it just to 0 just to create and initialize the variable. And then inside here, we're going to work out what that's going to be. So we know that we have our particle.colors. that is an array of colours that this particle can have. And what we want to do in here is we want to select a random one from that colours array. So we know that within this array then, we will have to pick out one of the values using its index. Now the indexes in Lua start at 1 and then go up to the length of the array. So we need to now pick out one of the values from this. So we're using our square brackets. And we want to use our math.random function. Now math.random lets us give it two values, and it will then choose an integer number between those two values, and including the two values as well. It's an inclusive range. So we want to start at 1, so from range of values from 1 to the length of our particle colours array. And we do that using the hash symbol, and we do particle.colours. And what this will do then, this will now choose a colour from this colours array. Okay, so the math.random will pick a number between 1 and the length of our array. We'll catch that in our particle colour variable, and we will then assign that to this particular particle. And again, because we're doing it inside the draw particles function, every time we go through the tick, it will change that colour. So we should get it now twinkling. So let's see if that works. Let's run that. So let's run that. Oh, and we've got something wrong here. So expected to close brackets near colours. So let's have a look. And yeah, I forgot to close that bracket in my math.random function. So we've now got the particle colour, we open the square brackets, and then we close the square brackets underneath there, like that. Okay, so let's try run that. And expected to close brackets near colours on line 810. So it's probably up here somewhere. So 810, 810, 810. And I forgot a comma after that one there. So there we go. So that gives us our correct function prototype. Okay, so let's run that then and see what happens. So in here, if I now shoot one, we can see that we now have our asteroids are giving us that nice sort of fiery effect as they move. Okay, so we've got the fiery effect happening, but again, all of our particles are exactly the same size. So let's work on that next. Okay, so we're going to want to be able to spawn particles at different sizes. But we need to have some sort of control over that. We can't just pick any random size. So what we'll do is we'll come in here and we will, when we spawn the particle, we will tell it what the maximum size is going to be. So we're going to have maximum size coming in as another parameter. So once that parameter comes in then, we're simply going to, for this particle, we need to store a size based upon this. Okay, so we've done the colours there. We're now going to change that, and we're going to do the particle size, and we're going to make that a random value. So math.random between 1 and this maximum size. Okay, so if we give in a value here of 4, then our size will be between 1 and 4 on a random basis. But by building it into the constructor, so this is where we're constructing our particle, by building it in here and assigning the size, then it will stay the same size for its whole lifetime, because we don't really want it changing size each time we draw it. Okay, this does then mean that when we come to draw our particle, at the moment we've got it at a fixed size of 2, but we now want to do it as particle dot size. And that should now give us random sizes. But of course, we need to now send that parameter in correctly. So if we go back to our explode, explode asteroid, and there we go. So we've got our particles, we've got our color, and then our next parameter then will be the maximum size. So let's have it up to size, let's up to size 3. Okay, and let's see what that does. Let's come in here. So we can see we've now got some small particles and some big particles. Okay, so that seems to be working well. And back into our code. What we also need then is, as our particles are moving, at the moment they're just moving at a constant velocity. But if you think about it, when things explode off something, they tend to slow down a little bit as they move. So let's add a deceleration factor into our asteroids. So again, when we spawn an asteroid, spawn a particle, we've got a maximum size value coming in here, and let's add a deceleration value to it. And again, we'll log that into our actual particle. So our deceleration value will be equal to this incoming value. So deceleration. Okay. And what we're going to do then is, as we move our particle, so as our particle moves then, once we've moved it, at that point, its speed, so we're going to adjust, so our particle dot velocity dot speed, we're going to simply take away that deceleration value from it, equal to, and again, it's particle dot velocity dot speed. Let's bring it down here. Speed minus particle dot deceleration. Now, of course, we don't want our particle speed going negative. We don't want it actually sort of rebounding on itself. So we're going to say then, so we're going to copy that again. So if our particle dot speed is less than 0, then we're going to make it equal to 0. And do that. So this should mean then that our particles will start off moving and then come down in speed. So let's see if we can now make that happen as well. So again, we've got to go back to our explode asteroid function. And we now know that we've got our spawn particle, so our position, velocity, lifetime, colors, maximum size, and then our deceleration value, and that wants to be sort of quite low. So let's do it 0.01 and see if that does anything for us. And what I'll do as well, I'll bump up the lifetime so that these asteroids last for a bit longer, so we should be able to see the slowing down a bit better. So let's do Control R and Z. And you can see there, you can see our particles, as they explode, they come to a standstill. Okay, so we're moving on quite well with these particle effects. So one last thing we can do to make these particles a bit more interesting then. At the moment they are all circles. So let's change it so we can have different shapes of particle. And we can have here, we can have single pixels, because at the moment, even if we have a particle size of 1, it's actually going to be a circle with diameter 2. So we want to have some pixels, individual pixels. We want to have our circles, but we also want to have maybe some rectangles. So we have 3 types of particle that this could be. So let's have a new parameter in here. So after our deceleration, we're going to have our particle type. So let me just bring this down one line so we can put it in here. So after this deceleration, it's going to be particle type, and that's going to be a number between 1 and 3, which will signify pixel particles, circle particles, and rectangle particles. So again, we do our math.random and give it a range of values, and that will then put in a random particle type between 1 and 3. So let's come down to our spawn particles code. And we know then that after deceleration, it's going to be our type. And after deceleration then, so we add that into our particle object. So we have that coming in. So at this point then, we've got everything into our particle. When we draw it then, we're now going to have to work out what type of particle to draw. So this is the bit that draws it at the moment, and that's going to be for our circle. So let's come in here, and we're going to say, so if particle dot type, so type, and we said that circles would be particle type 2, then we're going to draw the circle. So let's do that. And again, that's all the right size and the right color. So else if particle dot type equals 1, then that's going to be our pixel. And our pixels are drawn then using a pix command. Okay, so let's come down here. So we do pix. We then use our x and y coordinates, so I can copy those from here. So we have x and y coordinates, and then the color of the pixel. And I can drop that in there. So that will draw a pixel in our color at the position. And the last one then, we can just say, so else, this is where we're going to draw our rectangle. And let me just finish my if statement there. And we want to do, so rectangle, and that takes then an x and y position. X and y position, followed by a width and a height. And again, we're going to draw it as a square. So we're going to use that particle size here. So width will be particle size, height will be particle size, and then color will be particle color. So let's drop that in there. So if our particle type is 2, that's a circle. If it's particle type 1, that's a pixel. And then everything else then will be drawn as a rectangle using those size values. So let's give that a go and see if that works. So Control R. Oh, and we've got some more errors here. So this is at line number 869, and it looks like I've missed a comma or something. So line 869, and I've done double brackets. That's probably what it was. Right, so let's run that and see what happens. So Z to do that, and let's see if we can shoot something. There we have. Oh. There we have. If I can stay alive for long enough, we might be able to see it. So let's go here, and you can see we have some squares and pixels and so on. Let me just do that again just to make sure. You can see we've got individual pixels. We have some squares. We have our particle effects pretty much finished. So let's come back into our code, into here, and let's have a think about where else we need to add some of these particle effects. So if we go back to our explode asteroids function, so explode asteroids. Okay, so we've seen then that we have a block of code here. So this block of code generates our particles for this explosion. And we could simply copy that and then paste it into anywhere else where we need to have an explosion, and maybe fiddle with some of the parameters on that. But that breaks one of the principles of our programming. There's something called dry programming, which says do not repeat yourself. And really what would happen there is if we simply copy this around the place, then obviously if we change the way our particles work, then this code will no longer, we'll have to alter every single version of this code. So this is the ideal place where we need to extract a function. So I'm going to cut that out, and I'm going to create a new function just down here. So this is after our exploding. So I'm going to create a function called particle explosion. Particle explosion. So this will generate a set of particles for me. Now we're going to have to send in some parameters into that. And let's do our B. Right, okay. So we will obviously have to send in some sort of object which is going to give us where our particle needs to appear. Okay, so instead of asteroid dot position down here, this will now be our object dot position. We will want to send in, so let's work our way through here. We'll want to tell it how many particles to use. So we'll do num particles. Okay, and that will tell us how big our for loop's going to be. Okay, so our particle velocity, so speed, so we'll need a max speed as well. So let's give it a max speed value. So we can have different speeds for our particles. So that'll be max speed. So our direction then is going to be random. So our particle will be spawned at our object's position at this velocity we've just worked out. Our lifetime then, so let's put another parameter up here. So that will be max lifetime. And that will then come out here, and that will replace that 90. Our colors then, again, we'll have to send in some colors. So explosion, so our colors. That's our maximum size. So that will be max size, comma, max size of our particle. Our deceleration, deceleration, and that will then be in there. And then we know that our math.random 1 to 3 for the type of particle, and we can leave that as it is, because again, if we ever add new particles, because we're doing it through this particle explosion function, we simply just have to alter that one number in there, or we could go and make that an actual value at the top of the screen. But I'm just going to leave it here for now, just so we can get this lesson moving on. Moving towards finishing now. So we now have this function called particle explosion. So let's copy that. Okay, so that's how we're going to call our function. And then up here, where we had our explode asteroid stuff in here, we now need to fill in the values. Okay, so our particle explosion. So our object is actually going to be our asteroid. Our num particles is going to be, let's set it to 60. Our maximum speed of our particles, let's set that to, well, we had it at 1 before, didn't we? Our max lifetime, we had that set to 60 previously. Our colors is going to be explosion colors. That was our array we'd put before there. Our maximum size was up to size 3. And our deceleration value that we had was 0.01. So we should now find that that still works as it did before. Let's run that. I'll come in here. And we now are back to where we were. But we've now got this function that lets us generate explosions whenever we want. So let's come back out again. So let me copy that. Because obviously, we want to have an explosion happening when our player ship gets killed. So let's come up here to our do ship killed. See if we can get that to come on here. So do ship killed. And that is where we do the sound effect for our player ship being blown up. So let's paste that in there. Okay, so we're going to do a particle explosion. This is going to be our player ship. And the values for it then, I've completely forgotten what the values were for this. So let's go to particle explosion. So particle explosion. So particle explosion. Let me just copy this so I know what the values are. And we're going to do ship killed. Okay, so let me just put that in here so I can remember what the values are. So it's the object, the number of particles. So we want this to be a bigger explosion. So let's give it a really big explosion. Let's do 500 particles. We're going to have them spreading out quite a lot. So we'll start them off at speed 2. The lifetime, we'll take the lifetime up a bit as well. We'll use our explosion colors, same size, and because we're going a bit faster, let's just knock that up just slightly and see if that does something. So let me just take this back out now. Right, so this should now give us a nice big explosion when our ship gets killed. So let's run that. And let's try and get our ship to explode. And there we have a nice big explosion. Okay. And I think I saw on that first one then. Let me just try that again here. So let's see if we can make sure that our ship has got a clear restart when it starts. What I'm trying to look at is I think the explosion was still happening when our ship respawned. So let's die now. Yeah, so our explosion is still happening when our ship respawns. So let's come in here and let's increase that. And I suppose that makes sense. So our delay at the moment is 60 ticks, but our explosion takes 90 ticks. So let's take that up to 120 just to make sure that we stay off the screen long enough for the explosion to finish. Okay, so let's just run that and see what happens. And start that. And the explosion finishes by the time we get back on. Okay, so that pretty much does all of our explosion effects. Right, so we've got our ship effects and our explosions happening. And then of course when we die, we get a nice big explosion and that finishes that. Right, so back to our code. So that pretty much finishes off our particle explosion effects. So make sure that you save your work, and I will see you in the next lesson. Bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.